Hello and welcome to this video where we're going to have a look at the various uses of a function machine in different aspects of GCSE mathematics. To begin with, let's have a look at what a function machine is. So a function machine is a way of representing different operations that can be applied to an input, and whatever calculations are done to that input will then result in an output. This can be done with numbers, or it can be done with letters, so we'll have some questions involving algebra a little bit later on. The questions that often appear in GCSE exam papers can take many forms. In some cases, they may present you with a function machine already in this format. So they give you an input, so a number to put into the machine, and then ask you to work out what the output would be. So as an example, if we have an input of the number 5, this is going into this function machine. The first operation that is being done to it is multiplying it by 2, which would give us a result of 10. And then after that, we're going to add 3, which will give us an output of 13. So with an input of 5, the output would be 13. You may also be asked to give an input if you are presented with an output. So if I say the output is going to be 21, we may be asked to figure out what the input would be. In this case, you need to work backwards through the function machine. So working backwards, we have to undo everything the function machine has done. The last thing that happened to this 21 was it was added 3 to an unknown number. So if I'm working backwards through this machine, I need to undo the +3, which will be a -3, because minus is the opposite of add. So 21 minus 3 will give me an answer of 18. So 18 was the number that went into this machine to add 3 that gave me the 21. Now I need to undo the multiply by 2 to find out the input. The opposite of times by 2 is divide by 2. And so this number 18 is divided by 2 to get the input. My original number must have been 9. In these sorts of questions, it's always useful to make sure that your calculations work if you were going forwards through the machine. So just double checking, 9 times 2 is 18, then 18 add 3 is 21. If your calculation doesn't work, you know you've made a mistake, go back and check all the calculations. Let's have a look at another type of question you may be presented with. In this question, we are given the input and the output, and we are being presented with 2 possible calculations that could have been done to make that change. This is very flexible. You can make any calculation you want as long as it will work. So as an example, I could do 5 multiplied by 3, which would give me an interim selection of 15, and then to get from 15 up to 17, I would add 2. This would be a perfectly correct answer. I could also have done something completely different. I could have done 5 times 5 as an example to give me 25, and then from 25 down to 17 I could have subtracted 8. Any calculation that will work will be a correct answer in this situation. Now let's have a look at the situation where we involve algebra. So in this situation, we have got an input of 2a. The output is 6a plus 1, and we now need to figure out what the operations were. If you're presented in something in this format, you need to be a little bit more systematic in how you think about it. We need to turn 2a into 6a. You have two options of how you do that. You can either multiply this by 3, because 2a times 3 is 6a, or you could add 4a. However, I would always try and advise against adding more algebra inside the function machine. It's not wrong, it's just more likely to make mistakes if people are not quite on top of what happens when you simplify algebra. So personally, I would go with the multiply by 3, but both are correct for stages. Once we've got 2a times 3 to give us the 6a, we need to make the plus 1 on the end, and in both cases that just means we need to have the second operation as plus 1. Let's have a look at one more example with an algebra slant on it. So in this case, we've got an input of b, but an output of b minus 2 in brackets, and then 3 on the outside of the brackets. This case, you really need to be very confident with BIDMAS, because if you look at the output, you're trying to figure out what calculations were done to make this. Now, because we've got brackets involved, the first calculation that has to have been done if we knew the value of b was to minus 2. So that has to be the first box. So b minus 2 gives us the calculation in the brackets, and then when you've got a 3 on the outside, remember in algebra, if you've got a number attached to something with no gaps, that means it's being multiplied. So this entire thing is being multiplied by 3. So b minus 2, then multiplied by 3. Now there are several areas where this skill might be useful, even though it's not presented to you on the page using a function machine. The first of which is if you are being asked to make something a subject of a formula. So in this case, we're being asked to make c the subject of the formula d equals 3c plus 2. In these cases, if you're being asked to make c the subject of the formula, you need to put c as the input. We need to figure out what calculations have been done to c to end up with an output of d. Now, if we look at this calculation, the first thing that must have been happened to the value of c is that we've multiplied it by 3 to become 3c. So that's the first thing that has happened. We've multiplied it by 3. After we've multiplied the value of c by 3, we've then added 2. And that has provided us with an output of d. When we're now making c the subject of the formula, what we're going to do is start with this value of d and go backwards through this function machine. So going backwards through this, the first thing that happens to the d going backwards is the opposite of plus 2, which is minus 2. So d is going to have a minus 2 applied to it. After we've done that calculation, we need to do the opposite of multiply by 3, which is divide by 3. And so this entire d minus 2 is going to be divided by 3. And so these are both equal to each other. And so c being the subject, which just means the letter on its own, c is going to be equal to d minus 2 divided by 3. So c is now the subject of this formula. The final example we're going to go through is if we are being asked to solve an equation. There are many different methods of solving an equation, but here's one using a function machine. We're trying to solve the equation 5x minus 3 equals 17, which basically means we need to figure out what the value of x is. So x is what we want to find out. So in this case, x is now going to be our input. Using our equation, we need to figure out what calculations were done to that x. So the x is attached to this 5, which means that must have been x multiplied by 5. After x was multiplied by 5, minus 3 then took place, so we subtracted 3 from that result. And after that was all completed, the answer, the output, was 17. In order to figure out what x must have been when we started, we're going to work backwards through this machine, starting with the output of 17. So we're going to go backwards. So before we subtracted 3 to get 17, we can figure out what this intermediate step must have been by doing the opposite of minus 3, which is add 3. So 17 plus 3 must have been 20. And 20 is the answer we get when we do the x multiplied by 5. So the opposite of multiply by 5 is divide by 5. And so 20 divided by 5 is 4. Just double checking. 4 multiplied by 5 is 20. 20 minus 3 is 17. So in this case, we have now solved the equation x is equal to 4. This concludes a variety of different ways that you can have a look at function machines in various aspects of maths, whether you are presented with the function machine itself printed on an exam paper, in which case you're either working out inputs, outputs, or the operations themselves, or utilising a function machine to either make something a subject of a formula or to solve an equation. And this is the end of the video. Thank you for watching, and goodbye.